All right, thank you. So yeah, just brief introductions. As was said, I am a software engineer in tools and infrastructure here at Google, working with Kubernetes. And lately, I've been with Kubernetes for about almost 3 years now. The last year or so, I've been focusing on build, and also the whole time I've been working on like build and test stuff. It's been the last year, so I've been specifically working on our build system, improving our build system, and trying to use Bazel for everything. So trying to get away from the legacy system we have, which I'll get to shortly. So, title of my talk here is Building Kubernetes, a Go binary with Bazel. And as Jay talked about yesterday in his lightning talk, all you need to do is just run Gazelle and you're done. Just import rules Go. You run Gazelle, it generates all your build files, and everything is fantastic. It all works perfectly. You're done. You go home. That was easy. Obviously, that's not the whole story. So I'll kind of expand, and Kubernetes in particular is more than just a Go binary, and it's more than just a few Go binaries. It's they're a whole distributed system. And so sort of the process I've been working on has been making the whole build process and our whole set of artifacts that we need to build and produce and maintain and test using Bazel for all of those pieces. So sort of the overview of kind of what I'll try to go through today. I will quickly go over Kubernetes. I think it seems like, based on talks I've heard, most people here are pretty familiar with Kubernetes and containers. But if not, I'll just kind of quickly give just a little overview of what those are, just because that kind of sets up some of the ways we've approached problems, the team has approached problems in the past. I'll go over kind of how we currently do our builds, our official builds, and how we have been doing builds for the last few years. Sort of a little story time of sort of being able to adapt those kind of weird idiosyncrasies, I can't say the word, but you know what I mean. Adapting all the weird things that we're doing for our build into Bazel, and then kind of what's currently working, and then kind of some things that aren't working so well, and kind of problems we're still trying to face. So just a quick overview of Kubernetes and containers. So Kubernetes is an open source container orchestrator. So basically, if you have a cluster of nodes and you have a bunch of containers you want to run your microservices, Kubernetes handles all the stuff for you. It schedules your containers. It does health checking. There's a whole suite of things. I'm not going to really get into exactly what Kubernetes does because that can be its own hours-long talk, going into all sorts of details. But what's relevant to this talk is, it's basically, like I said, it's largely a Go project. But we have in just the core Kubernetes repository, there's a lot of shell for both the build as well as actually starting clusters and kind of all of those things. There's Docker files to build all of the things. There's make files, which we use for building a lot of components. There's YAML and JSON, which we use to configure the containers that run on Kubernetes. And then if you start to look in some of the sibling repositories that Kubernetes relies on as part of its components, there's some JavaScript for the dashboard and HTML. There's Salt for configuring clusters. There's Python for some of our infrastructure, test infrastructure in particular. So it there's a lot of different languages, but it's largely, at least the core parts are Go. It's on GitHub. I say it's monorepo-ish because currently there's the core Kubernetes repository is a monorepo, but there are these kind of additional things, additional components that are in separate repositories in our GitHub organization. And there's an effort underway to kind of start to split up the repository because we're running into all sorts of issues with development velocity having one single repository. All this is causing its own challenges. We have, I actually wrote 25 PRs merged per day. That's only in the core repository. If we look across all of them, it's much larger. We have 500 org members, which are people who are committed to have been committing to the project and actively engaged. There's even more people who are, still submitting PRs, kind of getting used to it. We have, over 100 unique PR authors per week in our repositories. And on our Slack channels, I think the main Kubernetes users channel has 24,000 people on it. I don't think most of them talk that much because that would be impossible, but there's a lot of people really engaged in this and really interested in Kubernetes and seeing it succeed. And kind of come with that, we kind of have a bunch of people that are developing Kubernetes in very diverse environments. So have a bunch of different Linux environments, not just Ubuntu, which is what Bazel likes. A lot of people develop on Mac OS. A lot of people use Mac OS, but they'll actually build on a machine in the cloud, or they'll do all sorts of other weird things. And we'll get into more of that. So kind of have people working on a lot of different things. Thankfully, I'm not aware of a lot of people developing on Windows yet, but I'm sure that's only a matter of time before that happens. So just kind of a little overview of the idea behind containers. If you're familiar with kind of the old way of handling things was that you sort of used VMs to segment applications. And so you'd create a VM, and you would kind of set up the OS as you needed. You put the libraries in that VM, And then all of your apps would basically run in the same namespace. And so sort of you kind of were stuck with the same libraries for all of those. Maintaining this was kind of difficult, and upgrades were difficult. It was just kind of very heavyweight. And if you wanted separation, you kind of had to create VMs. VMs are slow to create and tear down. It's just kind of a clunky way of handling things. So containers are kind of this new idea where you basically just package up your application libraries you need only for that. And so you have an idea of these like lightweight containers that have only the things that your app needs. And so kind of what I've sort of implied with some of the colors here is that like you have different containers with different dependencies in them. And so that lets you basically, you can replace things easily. And then you've got isolation between containers, so you don't have to, I was going with that a lot, but you get isolation, so it kind of makes management a lot easier. And so Kubernetes kind of builds on these concepts. And so, kind of, it's still pretty simplified, but you can, start to think, okay, now approaching more like a Kubernetes cluster, you have multiple hosts. You can create networks between the various hosts. You can create networks inside a single host. You have volumes you can attach to these if you need, like persistent storage and other things. And so kind of this gets much, much more complicated. And so Kubernetes kind of handles all these things for you. But that's kind of like where, Kubernetes approaches sorts of things. So various components, this is only a subset of some of the things, some of the outputs that we build from a core Kubernetes cluster. Excuse me. So we have like a Kubernetes master, which sort of manages the cluster. And so there's basically the, what I'm showing here in this picture basically is things that are like kind of the double circles or the double oval squares here. That's kind of indicating something that's Dockerized, whereas other things run just directly on the host. So for example, kubelet and Docker run on all of the machines. Kubelet is kind of the thing that manages Docker containers running on those machines. Docker is what actually manages the containers themselves. So kind of kubelet talks to the API server to figure out what needs to be run. And so then the rest of the Kubernetes components actually run inside the Kubernetes cluster itself. So there's kind of this bootstrapping process, but like a lot of these components are basically all running inside the Kubernetes cluster. So we're very heavily, everything is containerized except for like the very bare metal or base stuff that can't run inside that. And so like, some of the things in dark green are kind of part of the core Kubernetes distribution, but then there's like other things like Kube add-on manager is kind of in a separate build process. The kubedns is in a completely separate repository, and so it has its own build process. etcd is something we depend on as a third-party dependency. We work with them. It's produced by CoreOS, but it's not part of our build process. Similarly, Kubernetes dashboard is another thing that's another kind of accessory component. So these are kind of all things that run on Kubernetes clusters, but they're all kind of in separate build systems, in separate repositories in different ways. And then down at the bottom there, I have kind of some client binaries. So these are ways that users of Kubernetes might interact with their clusters. So you have kubedum, I like to have a funny pronunciation, which is a tool you can use to start up clusters, or kubectl, how you basically create jobs, manage jobs. And then like we have EV test binaries that we run against clusters developers run to make sure the Kubernetes clusters are working. So how we kind of handle this with the non-Bazel process. So more background, for those of you not familiar with Go build system, basically Go was created, I don't know, 10 years ago or so. And I suspect it kind of used a lot of the concepts that had been kind of thought about inside Google with Blaze and some of the build systems there. And so they kind of tried, plus other technologies and other things that have kind of come about since the days of C and C++. And so they have a pretty sophisticated build system, or it's fairly sophisticated, obviously not nearly as sophisticated as Bazel, but at least for Go, native Go code, it's has a lot of stuff that comes with it. So basically you can just say Go build, and inside the Go files, you have all your dependencies you need. And so it basically knows how to build that. You don't have to really tell it anything more. It just knows how to build. It knows what it needs to build. And then Go install basically will not only compile things, but also will install them to your Go path bin directory. You have a tool called Go Get, where you can say something like Go Get github.com/xd/blah, blah, blah. And it'll basically go and download that package, build it, install it. So this is a way you can very easily download tools, things like that. Go Test runs tests. It's pretty straightforward. Go Format will format code. So there's basically an opinionated formatting built into Go. You have Go Run, which is a lot like Bazel Run, where it'll build it and then run whatever that command is. And then Go Generate, which is a way of being able to generate code with Go, where you sort of, in your comments and Go files, indicate some shell commands or something you would run. So if you run Go Generate, and some source file would actually look at that source file, figure out what it needs to do, and then generate that code. Unfortunately, Go generate's not kind of chained as part of something. So if you have a Go dependency that depends on something that's Go generate, you have to generate it first and then go build. There's not kind of any sort of chaining there, and that's one difficulty with that. Another thing is Go has a very opinionated way you're supposed to structure your directory tree. So you create a Go path. You can put the Go path wherever you want, and then you set an environment variable called Go path. And so inside there's a Go path /bin, which is where all your dependents, or everything you've built, all your binaries will get put in there. You have package, which is where sort of the intermediate libraries that are built in object code go, and then Go path source. And that's where all your source goes. And it's kind of organized in this URL format. So like, github.com/project1. So basically, if you have a Git repository that's in GitHub project 1, it would live under Go path source that. Similarly, you have like hits.io, Kubernetes, test infra, other things under there. And so basically, you put all your code inside the Go path, and then you can basically refer to it. You would import these, like I would import hits.io/Kubernetes/ some package, whatever, and Go would know to look in the Go path in the right place to pick up that dependency. Around the Go, I think it was 1.5 or 1.6 or so, they introduced a formal way of vendoring code native to Go. Previously, we'll get to in a minute. There was a previous to vendoring, there were other ways of handling this. But basically, in your basic workspace, so like in case.io/Kubernetes, I have a vendor directory. And inside there, I basically put all the sources I need that I depend on, the third-party dependencies. And so I kind of have an example here of like some things that might exist in the Kubernetes one. So managing this vendor directory, there are many different ways of doing that. The first one I list here, GoDep, which is one word, is not an official Go project. I think it's a project from GitHub. And this used to be, before vendor was a thing, there was a tool called, there was GoDep, and it would create a GoDeps directory in your workspace. And basically, when you built, you either wrapped a Go build or a Go test or whatever with GoDep first. And it basically would munge your Go path environment variable to point to everything that's in the GoDeps. You could also extract or copy everything that was from your GoDeps into your actual Go path. It was kind of a huge pain to maintain this. So sort of vendoring kind of at least solidified or at least formalized the way that Go could natively handle these vendoring things. There are other tools. There's Glide. There's a GoDep, which is from the Go team, which is a newer thing. Currently, Kubernetes uses GoDep, the first one. Our test info repository recently switched to GoDep, the second one. There are other ways of doing it. In some cases, these can be super frustrating when people just kind of like manually manage all of them and just copy files directly into the vendor directory. It's not a great story, but that's kind of how it is. It's still kind of evolving. Like I said, Go 1.5 was a year or two ago, and so I think it was turned on by default in 1.6, 1.7. I can't remember exactly. So some other things, the Go build system, you can kind of control various ways Go operates and the outputs you get by specifying environment variables when you run the various Go tools. So CGO is a way that you can link Go code against C libraries and C code. And so there's like a way basically in your Go program, your Go sources, if you like have a certain way of writing your code, you're now depending on some C code, and you would link against that. If you want to sort of, a lot of libraries, like for example, the Go standard library has some C Go dependencies, but there are ways you can sort of get back to a pure Go mode. And so you specify this environment variable CGO enabled equals 0, which will force you to the pure Go mode. Similarly, if you want to, well, not similarly, but if you wish to cross build, there's Goose and Gorch, which you can specify to basically specify the OS or the architecture that you're targeting. And similarly, like if you want to do some weird things, like you have a separate Go root, like you have a separate Go installation somewhere, you can change your Go root, which will basically point where the standard library and other things you need to use are. And so, too far. So that's kind of background roughly of sort of at least kind of Kubernetes containers and overall just kind of how Go builds work, just as a little bit of background. Now I've used up like half my time. So basically, the build inputs for Kubernetes, obviously you have Go sources. We have like the data files I mentioned, so like the salt scripts and YAML files and JSON things. Those kind of all are kind of inputs to our build. They're all in our repository. We have various Docker base images. So we have like the upstream Docker Hub BusyBox we use for some of our images. Mostly we use BusyBox just for debugging. It's nicer if you can actually connect into a container to look and see what's going on. We also have the kube proxy. One of our components requires modifying IP tables on the hosts. And so basically, we need a container that has IP tables in it. And the easiest way to get IP tables is based on Debian. So we have a Debian-based image that has IP tables installed in already. We create these base images mostly for efficiency when building all of our containers, because if you have to download and then apt-get install IP tables, that just is very slow. So kind of having these just statically helps a lot. And then we also have this cross-build image, which I'll get to in a minute. It basically is kind of based on a Golang image, but involves a lot of extra cross tools that we need to be able to cross-build a bunch of different targets. And then kind of the other input is like, what do you actually want to build or test, and what platforms you wish to target. So the outputs. So the very basic part, which was originally for this talk, is Go binaries. It's a little more complicated though, because we basically want to target almost every single platform that Go supports. So we support, you probably can't even read that, but it's like a whole bunch of different Linux architectures. We also support Darwin. We also support Windows. Some of these we use in pure Go mode, not all of them. So some of them are dynamically linked. We pull in C code. Some of them we don't. It's kind of a mix. We also then build Docker images for all of these. Well, not all of these images, but Docker images for a lot of these images, or for a lot of these binaries, a lot of the server binaries. And then we basically have Docker images for each architecture of those binaries, and we save those as Docker tar files as well that we can sideload, in addition to pushing them to a Docker registry. And then we basically take all these outputs and a lot of these configuration files and other things, and we compile them into tarballs that we then upload to Google Cloud Storage. And some of these are platform agnostic, where there's like shell scripts or the tests, which are strangely all architectures in one. But a lot of them we've basically separated out into separate platforms. So like we have a Kubernetes server tarball for Linux ARM, for Linux AMD64, for Linux PBC64LE, et cetera. And so kind of we have all those. We additionally then also build RPMs and Debians of a bunch of these components. These are not currently actually part of our core build system, but it's something we'd like to be able to do as part of our core build. So kind of, it may already be obvious just from the list of outputs, but kind of the Go tools by themselves are really not giving us everything we need. One problem is that as Go versions are constantly updating, the versions of Go that people have on their workstations may not necessarily be the same, may not be correct. So if we want to be able to sort of always be using the same Go version, which have different features, different security fixes, and so forth, we need to be able to kind of ensure that everyone's using the same version of Go. And similarly, like we need to be able to, we want to make sure that's, we're all Bazel people here. We know we want to have hermetic and reproducible builds, and Go doesn't really give you that by default. Especially another thing is like Go paths can leak, and so depending what you have in your Go path, you may be pulling in extra dependencies you don't know about, or the wrong version of dependencies. Vendor has helped a bit with this, but if you forget to put something in Vendor, you have it in your Go path, it'll build fine. Now, if you upload it up and you submit a patch and it goes in, we don't have that in our Vendor, now the build's going to break because you had that dependency locally, but we don't have it. So we kind of need to be able to wrap that and hermeticize that. Another thing is basically for a lot of our CI, the Go tools are kind of great for humans, but if you want to be able to machine parse or kind of get test results trending, for example, if you want to see like, know exactly which tests failed and be able to like create pretty graphs on Jenkins or other CI systems like that, it's not, you have to like parse the machine output, which is constantly changing, which is not great. So we're basically we actually have a tool which we're using a tool somebody wrote, which will read that output and kind of create a JUnit file you can use. And so we have scripts that kind of do all of that and do it in a parallel way and support code coverage and all sorts of other things. And it's kind of this huge, hairy mess of stuff that wraps around it. And I already touched on it as well, but generated code is also, not really built into the Go build process and something you have to handle outside of that. And so that's, runs into problems. So, kind of, I guess, because we have some old C++ programmers on the team, the overall, basically, interface that everyone uses, or at least the main interface, is through make. There's actually a lot of shell hidden behind the make. I wrote here, 17,000 lines of code. It's not all part of the make process, but for a lot of other various things, there's just a lot of shell in our repository. And so, it's kind of a nice interface. You can say, if you just do make, it'll just basically build everything. If you do make what equals command kubectl, it'll just build that component. Make test will, run those tests that's in that package. Make verify runs a whole bunch of verify checks and lint checks, which I'll get to in a minute. And then there's make release and make release, which are basically our ways of building the whole release. And so as opposed to just building one little component, it builds it in a hermetic fashion. Quick release is like make release, except it only targets Linux AMD64 because building all of those platforms is very slow. And the make clean is hopefully obvious. So what does make release actually do? How do we sort of achieve this hermetic-ish build without Bazel? So first, well, it's all driven by shell scripts, of course. So first, we set up a build container. So basically, again, going back to this, everything in Kubernetes, we think in containers. So we set up a build container using our cross-build image. Then we rsync all of our sources into this and get everything into the right Go path. And then we basically have a list of things we want to build. So we go install, which is faster, or go build, which is slower, depending on sort of whether the environment is correct. We then rsync everything back out of the build container after we've done these builds, which takes 10 minutes at least per architecture. And then we go and we build all of our Docker images and save, and then we go and we create our tarballs. So super easy and great. So yeah, I was just mentioning the cross-build image. So basically, we version this with Kubernetes release because a certain Kubernetes release was usually built with a particular version of Go. So we basically take the Golang image, we pre-compile the Go standard lib for all the various architectures in pure Go mode. We add in the protocol buffer compiler. We create cross-build tools. We apt-get install those, and some other various things that we use in some of our unit tests. And so basically, this is a way, without this, you'd sort of have to be downloading all this stuff every time you build or something. That just ends up being very slow. So obviously, this is kind of a little bit of a mess. The make files, I didn't even really get into the make files, but there's make files for generated code that are hundreds or 1,000 lines long. There's even more shell scripts that do all sorts of terrifying things. Incremental builds are really slow. I think, if we just do a make what equals blah without using the cross-build container, it's fairly fast and fairly incremental. But if you're trying to do a release, which you need basically in order to build a cluster, this takes, even a no-op will take like 5 minutes to do nothing, basically. So that's not great. Builds on Mac OS kind of work. The rsyncing bit here that I mentioned was at least partially for supporting Mac OS, because apparently, at least at one point in time, the volume driver on Mac was kind of slow. And additionally, some developers would have a Docker instance that was in a VM in a cloud or something. And so they basically wanted to use this rsyncing to get their code up there to build there because their Mac was slower or something. But you end up with all this extra complexity that becomes super difficult to debug. The other thing is that we run into issues. They're all a bunch of shell scripts. And a lot of the POSIX tools on Mac OS are different in subtle ways. Sed has slightly different flags. grep has different flags. chars has different flags. And we don't really have CI on Mac, and so people will check in things, they'll fix things, they seem fine, they pass our CI, and then we find out later that we completely broke the Mac build, and developers get unhappy. So it's not great. As I also mentioned, we don't really have, this currently doesn't have a way of building RPMs or debs. That's all handled out of band, which is not great. We pretty much every time we cut a release, usually somebody comes back a day later, so it says, hey, where are the RPMs? And we have to go and build them, which is not great. And then generate code. I'm just going to keep refraining generate code as a big pain. Generate code. That's what I'm going to talk about. So we have this make file that basically there's a whole bunch of utilities. This is only a subset of the stuff that we kind of build. But basically, there's a bunch of things that for performance reasons or other reasons, we pretty much have to generate code in order to do everything we need. So the Kubernetes client library is generated because there's basically a lot of repeated code and things like that. Or we sort of have a specification of how things build, and then we have to generate all of the Go code that actually implements that. There's things for API conversion. The idea behind this is that as the Kubernetes API that clients use to interact with changes, we want to basically have some code that will automatically translate things such that we have some backward compatibility. Deep copies of things. There is a way you can do deep copies of the reflection. It's really slow. So we basically we generate code that makes that faster. Open API definitions is another thing. Generate, I'm not going to read everything here, but there's basically a whole bunch of stuff that we have to generate. And we basically all check it in because it can be kind of slow to generate this. And there's at least some desire to be able to, I think still, I don't know if it actually still works, but at least at one point you could sort of go build without using our build system. But the only way to do that would be to have the generated code checked in. think that's all I want to say that. So, and yeah, so one of the patterns we often use, so I guess one of the issues with this is that this generated code often causes merge conflicts, which will basically cause developers, when their PR will be all ready to merge, they have to go rebase, regenerate everything. This can cause a huge amount of pain, particularly for newer developers, but for everyone, it's just a pain. And kind of one of the patterns we use, which we'll get to later, or you'll kind of see, is that, I didn't actually mention this, but one of the things that Go does is you can have comments at the top of your file that look kind of like with a plus or minus, and these are build tags. And so Go build, you can basically say, you can give Go build tags, which will include or exclude certain source files. And so we use these Kate's build tags to basically, for our generated codes, we have these various code generators, and we'll basically go scan our tree, look for this Kate's OpenAI API gen tag, and then use that when generating the OpenAPI specs. So because we have all this generated code and other things, we end up having this hack directory, which has all of these update files and verify files. And there's so many of the verify ones, they go off the bottom of the screen, which was intentional. But so there's like, updating all these various things. And basically, we have this update all and these verify all scripts. And so generally, if you're doing any sort of non-trivial change in Kubernetes, you just run the update all script and just like whatever it changes, you check in, you upload. And then in CI, when you create a PR, we run this verify all check, and hopefully everything's fine. If not, it'll tell you what failed. Some of them are more reasonable. Like we have some that are, there's like a Go format and a Go lint check and a Go vet check. And these are kind of reasonable. They'll do reasonable things, and people are fine to fix those. Whereas some of the other ones are more frustrating. There's Go depths in here, which is another one which we use to manage some of our Go dependency stuff, which is another thing. And you'll notice if you're looking carefully, you'll see there's an update Bazel and verify Bazel, which I'll get to in a bit. So yeah, so about a year ago, I started, well, I should say we started working on trying to get Kubernetes to build with Bazel. And so, kind of the initial focus, and I say still the focus, is trying to get full parity with everything that we've built. We wanted to make sure the developer experience was no worse. As much as pain as I indicated that was, it still works. It's kind of slow. It's kind of painful for people maintaining the build to figure out. But for most developers, it mostly just works. And so we don't want to make it any more painful. And another thing is we didn't really want it to be seen that like, Bazel is a Google project. Kubernetes was originally a Google project. We didn't want to be seen as like forcing this kind of new untested project on the Kubernetes project, which potentially cause a lot of problems. Because at least at the time, and possibly still, I think we might be the largest Go project trying to use this, or at least publicly known. So it was kind of, some people were initially worried that like, we're kind of the guinea pig for this thing that nobody else is using. Why are we doing this? So trying to make sure that everything still works, not get in anyone's way, but hopefully improve things and demonstrate that Bazel is really helpful. Gazelle existed about a year ago, but at the time it did not support native Go vendoring. It only supported the Bazel vendoring, I believe. And so Mike Denise, who's somebody on the Kubernetes team up in Seattle, worked on this tool called Bazel, which basically does much of the same thing as Gazelle does, except that it, at the time, supported the vendor directory. There we go. And like one of the key things we had with that was that we had this idea, we added an auto-manage tag to all of the rules it generated, such that like if you needed to override things in certain cases, you could remove this tag and Gazelle would no longer touch it. Ran pretty quickly, which was important, so we were able to add it to the update and verify scripts. And basically what that ended up becoming is that it just became part of the thing that every developer runs. They run update all, they run verify all, and it's a quick script, so it didn't really add a whole lot of pain. It generates some build files, did some things people really didn't know about, didn't really care about, hopefully, and people just got on their way. It was just another generated thing, so that's fine. And another advantage of that is that we also got build auto formatting because we're running this all the time. And then there was configuration file, which most people didn't really ever need to touch, but just lived with the repository. So we'd have different settings on different repositories. And so as of like last December or so, we actually had build files all throughout the Kubernetes tree. We were able to build all the binaries. We were able to run unit tests. We could build the Docker images. We didn't really have the ability to start a cluster, but we had the beginnings of, we could actually do some Bazel builds and starting to see some stuff. We also Bazelified our test info repo, which was much simpler, but was also kind of a great place for us to kind of test out things that were in a more simpler setup. There was a fun incident at first where in the Kubernetes core repository, we have a build / directory. And so we created a build file in the root and discovered at some point, again, our poor Mac OS users were having issues checking out the Git repository. So for a short period of time, we renamed build to, I think, build tools or something until we got build.bazel. And then we flipped back, and now we have a build.bazel file in our root, which solved that problem. So kind of the next thing I started working on early 2017 was trying to build all of the release tarballs using Bazel, which was kind of a core thing to be able to start up a Kubernetes cluster. And so we kind of have a bunch of different outputs here. So we have this manifest tarball, which is just sort of all of the text files and configuration things. Salt, which is more configuration files in a particular tree structure. The source, which was basically our entire source tree, which we needed to include for various reasons. We have a test tarball, which was all of the Go test binaries, EDB test binaries. So it wasn't all of the unit tests, integration tests, but like our EDB tests are built as a single binary artifact, and you can just run that, and it'll basically run all the EDB tests against a cluster. Then we had server node and client tarballs that were basically per OS and per architecture. And so these had all the binaries built for that particular architecture. And then there was a overarching sort of Kubernetes.tarta.gz, which basically just had a few extra scripts, some readmes. Basically, you could download this, and then there was a script inside that which would download everything else you needed for the architecture you were targeting. And also had some version information in it. So it had some Git stamping. So sort of one of the first challenges was the source tarball. I wanted to be able to include all of our sources in something in a Bazel rule, but Bazel doesn't really like you doing this for obvious reasons. And so I kind of was looking around trying to figure out the best way to do this. Well, and the reason I didn't just try to do this outside of Bazel is because for various reasons, we need to include this inside our server and node tarballs. And so unless I did that first and then ran Bazel, it was kind of weird. And it's like, well, if I lose that, then I lose being able to build all these tarballs inside Bazel. And that was, I wanted to be able to do as much in Bazel as I could. So I kind of started looking at other options or seeing what other people did. And so I looked at the Bazel project, and I noticed they had some sources file groups. It looked like they were manually curated. And I was kind of worried about that because we had a lot of build files, and I was worried that people were not going to want to maintain these things. They're going to get out of date. So it wasn't going to work. But since we're already using Bazel, it was just easy just to write a little thing that basically added additional rules. So we have these, maybe you can read them. There's a package sources and an all sources rule that basically exist in every single build file in our tree. The package sources is just a glob for that package. And then all sources basically is recursive, including this package plus everything below it. I separated those basically because I figured package sources might want to be manually managed if you needed to exclude things. Like in our root, we had some weird files we needed to exclude. Whereas all sources were intended to just be auto-managed completely and never touched. That's actually worked pretty well, surprisingly. So another pain, which I really should have used larger fonts, but these are kind of just some real rules actually from our tree. But again, we had sort of a very particular structure of how we needed to organize binaries inside our tarballs. So everything expected, there was a Kubernetes directory, and inside Kubernetes, it was Kubernetes/server/ architecture/bin or something like that. And so we kind of needed to get all these things in the right place. But we also had a Kubernetes server add-ons directory and other things. And so we kind of had to I built all these intermediary tar rules to basically be able to get everything into the right structure. So this is one example, but I have others that I've done. I think some of this may have been fixed, possibly. I haven't managed to apply it yet, but that's kind of one little hack I kind of had to do is this was the easiest way to basically be able to put everything into the right place, but ended up meaning that we had a lot of intermediary tars, which was not great. Other problems. This is one I kind of referenced the end of yesterday with my question at the end of the Ask Me Anything, was that the official package tar rule, or at least the actual archiver that implements this, prepends everything with /. And so our tarballs were just Kubernetes / blah, blah, blah. The ones produced by Bazel were ./Kubernetes / blah, 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 blah. This is mostly fine, except that Bazel set the permissions on dot to read only or something. And so if you would extract this tar in a place that you weren't privileged, or if I tried to extract this in temp, for example, I couldn't set permissions on the temp directory and it would fail. And this was kind of not a matching parity. It was kind of painful, And I was like, well, it seems like this should be fine. I can just change this, which of course was a joke. Or at least it was a lot less trivial than I expected. So I was able to change this pretty easily. I was able to change the local test pretty easily. That was fine. And then I went and it kind of started to break more things and more things. And eventually I kind of gave up. So we're currently still using a fork of this in my repository, which kind of removes that. I might maybe check in something that lets you give an option. I just haven't had a chance to go back. I've been so dejected the last few months with that getting reverted several times. The other thing is that actually the script itself is extremely slow, especially with the Kubernetes source tarball. Pretty much all of them, because it's because it's a Python program and it's single-threaded, creating these tarballs, which some of them are several hundred megs in size, is taking many, many seconds or minutes. And it's actually one of the slowest parts of our build right now. And so Mike Denise, again, actually has a PR where he basically wrote a Go program which implements the archiver program with all the things we need. And thankfully, because of some of the flexibility in the package tarball, we can actually just point to that and say, this is the archive tool. And I think it cuts our build down to like 35 seconds from 5 minutes or something. So it's a huge improvement. So I don't know how well, there's something you can upstream, because I don't know if we want to have additional dependencies on Go. But at least for us, it's potentially a huge win. And before that worked, there was kind of another hack. I found config settings. And so I realized that for most CI builds, so for an official release, we would need to include all of the sources. But for a CI build or developer build, we don't really care about the source tarball. So I'll just like have a little flag that I can specify configuration. And in some cases, I just have a README that says, well, we didn't include this. In other cases, you include the real thing. This helped a lot, creating that. And then we weren't recreating the source tarball every time we touched any file. We weren't recreating all the additional tarballs every time we changed one file. So another thing was, like I said, we had we distribute our E2E tests as a test binary. And at least at the time, and possibly still, there's no way to like exactly get at that test output, or at least not have it named the right thing. So this is just a simple little rename general, where basically we depend on the Go test. We set the flag or a tag on the test, so we don't run it all the time. We have some filters, so we skip E2E. But we basically can depend on E2E.test, which is what we need. It'll build the Go test. It'll then run the general, which renames it. Super easy. Although maybe there's a better way to do this. Another thing is, early on, the Bazel tool, we decided that we would just basically have a single build file for the entire vendor directory. I believe this was done mostly because it was simpler to reason about and made more sense possibly to not litter build files throughout vendor. We weren't really supposed to be touching things in there. It was just, we were just copying files in and then generating stuff. We discovered this had a huge problem because, again, with lots of contributors constantly updating things, this would cause rebase conflicts constantly. This was a huge source of pain. Some people were like threatening to completely remove the Bazel stuff at some point. And so we rewrote Bazel. So basically we'd use multi-build files. So we had build file in each package. And this is multiple files. Build files is what Bazel does. And so that was kind of a interesting lesson, but that's kind of what we ended up doing in the end there. So sort of we managed to get some of our generated code into Bazel. So one of the easier ones is Go bin data, which I think there's actually a cleaner example in the Go rules repository, but this was kind of before that. We already had Go bin data inside our vendor directory because we were using it for some reason. We basically already wanted it hermetic, so we already had it. So it's just easy to depend on that tool and then just run it like a standard general. So you can read it through there. It's just really, really straightforward, pretty easy. You just give the sources you need, and it just runs and generates the thing you need, and it's amazing. Some of our tools require a valid Go path and a Go standard library and Go root and all these things. And so we wrote a custom rule in Skylark, which called Go general, which basically wraps general with the creating a valid Go path and Go root first. And so it basically creates a temp directory, copies some things in, symlinks I think it actually symlinks, not copies, but symlinks some things, sends some environment variables, and then you can use that to run these code gens that need that. Unfortunately, this has been kind of broken a fair bit by Rules Go. I think it's slowing down a little bit, but a lot of the tool changes and other things have been making it so like every time we update our Go rules, things break. But it's part of the joy of being an early adopter, I guess. Yeah, so as I was explaining kind of earlier, one of the generated things, example here is the OpenAPI library rules. So basically, in Go files, in the files that need OpenAPI definitions, they have this comment that basically enables that. And then, but the problem with that is that there's no great way to say like, hey Bazel, I want to depend on all the things that have this tag in a file. So the kind of the way we fix this, at least for now, is well, we just added another thing to Bazel, and so we basically we're already walking the tree, so we can walk the tree and look for that. And we created an OpenAPI library macro, which wraps Go general, which I just mentioned, and basically Bazel will fill in a list of sources that have this tag that get passed and creates an OpenAPI library rule or instance using that. So, oops, so that's all I have. So basically, just has OpenAPI library, and it lists all of the things that have this particular tag. And so, sort of, we are able to build this list out of band, out of Bazel. It'd be nice if you could figure out some way of doing this more inside Bazel, but this is kind of what we have for now. And there's a whole bunch of other examples of things like that. Basically, all these cases where we have these build tags, we want to be able to sort of select only on those files. I'm not sure how we would do that without walking the whole tree. Possibly we could revert the way we do this, and instead of having the tag in the file itself, we maintain a list. But that's kind of not the way we currently do it, and so we'd probably have some friction converting developers to go to that sort of model. How much time do I have? Am I already past my time? Okay. Got it. Yeah, sorry, I totally have not been paying attention. Yeah, so just quickly skim through this. I had way too much stuff, I guess. So stamping was important. We implemented some various ways. So another thing we needed basically was be able to include all of the get information in all of these binaries. And so basically implemented rules in, we created a workspace status command, which basically was able to map all the stuff into Bazel, which created these workspace status files, then updated the Docker rules and Go rules, or worked with Matt and Jay and Ian and other people to update all these rules such that basically we could use, well, so this is just using a general with that, basically being able to stamp a Docker tag. So getting a Docker tag that has that particular version in it, being able to link Go binaries with that. So basically, we have kind of this little rule here. So basically, just specifying some linker flags, which include those files. One issue with stamping is that it's not really standardized. Like, kind of, there's a sort of standard way we do it with that's similar for Go and for Docker, but other rules, it's kind of everyone's on their own. It's not really well documented either. So it seems like that's kind of a place for improvements. Currently things are working. There's still things to improve. And other people in the community are actually starting to adopt it, which is pretty exciting. So some of the other projects are starting to look into it, and they're kind of enthusiastic about using it. A few things, generated code is still not a great story, as I mentioned. Sometimes, the documentation is improving, but it can be somewhat lacking sometimes. We get some really weird error messages people run into that can be bewildering. Again, I think there's improvements. It looks like the documentation is improving for other distributions, but kind of Ubuntu is still sort of the main one. Things are constantly moving. So one of the ways we've kind of helped with that is we basically so we have many different versions of Kubernetes that go back like 9 months that we have to maintain. So we end up creating a container called Planter, because it's Bazel in a container, that basically lets us wrap up Bazel inside a container. And you can just run the script, and basically it'll map everything for you. Lets it run Bazel as if you're running it locally. It's a little slower, but basically does all the things for you. And so you can very easily switch Bazel versions. Another thing is like just sort of being able to add dependencies, Debian dependencies to an image can be really frustrating, especially because the mirrors will often drop those dependencies. So this is why we're still sort of using base images we build outside Bazel with Docker files. Would love to improve that, but it's kind of a pain. This whole Go vendoring versus Bazel vendoring is kind of difficult. And also the way of dropping your dependencies into a vendor directory. If you drop in a native Bazel project, now all your paths inside your build files is wrong. How do we fix that? I don't know. There's, you can use Bulldozer possibly, but it's frustrating. Another thing is we've tried to write some lint checks like using these all sources rules. They don't work great. I don't know if it's something that people want to do or if this is something that's a good idea or not, but it's kind of been a little issue. Another thing is, we have on our CI, we are trying to improve things. We have a SSD persistent disk, but we have had some issues, and there's not really an official way to do this. We're kind of abusing the test tempter to be able to use this, but maybe there's a better way. And then, of course, cross-build support. And not everything is cross-build for everything. So we have to figure out, like, these tarbells, we want to include some things. We want to include some of these tarbells, but not all of them. So I'll leave with this one parting response, which was an unprompted comment from somebody on Slack, which was, by the way, XD, MML, Ben the Elder, Bazel is bloody amazing. Bazel to him has made my life so much more productive. Cops test took 6 minutes when cache we were at 30 seconds. I don't cluster open channels, stunned, free ends. So that was a quick speed through the end of my presentation. You can find me on GitHub and Slack at XD or Twitter at jgrafton. We have a pretty active channel on the Kubernetes Slack at Bazel, and then there's also a fairly new Bazel Go Discuss mailing list set up by the Rules Go team. So thank you to everyone.